Alright, hi. Welcome to the fifth problem of the series. So this looks a very simple, short and sweet question. Two particles, 1 and 2, move with constant velocities v1 and v2. At the initial moment, the radius vectors are equal to r1 and r2. So you basically know the position of the two particles initially. Now what the question is asking is how must these four vectors be interrelated for the particles to collide? So let's take a frame on ground as our origin frame. Oh, and this is particle 1. Let's just mark it with blue, right? And this is our particle 2. So the position of 1 with respect to origin is r1 vector. Position of 2 with respect to origin is r2 vector. Now velocity of 2 को मैंने कुछ तो v2 vector मान लिया, and velocity of 1 is v1 vector, arbitrary vectors, okay? But these will remain constant with respect to time. So the concept used in this question is that of relative velocity. If you look at it, it is a very simple question, relative velocity. So when velocity of particle 2 with respect to 1 is equal to velocity of 2 with respect to chosen frame O minus velocity of 1 with respect to chosen frame O. And this comes directly from the position or the coordinates of the particle with respect to the origin, or shifting of origin basically. So coordinates of 2 with respect to 1 is equal to coordinates of 2 with respect to origin minus coordinates of 1 with respect to origin. And इसको differentiate किया तो velocity का relation आता है obviously, because dr vector by dt is nothing but v vector. So if you look at it, अगर मैंने ऐसे आर्बिट्री डायरेक्शन लिया कोई एंड सोचा कि मैं इसके फ्रेम पे बैठ गया एंड आई एम लुकिंग एट पार्टिकल 2 एंड इट अपीयर्स कि पार्टिकल 2 इज मूविंग समवॉट लाइक दिस, okay, and this is the line joining the two particles and a constant velocity से जाएगा, right, because the velocity of each is constant, so velocity of 2 with respect to 1 will also be constant. So ऐसे जाते हुए देखिएगा. Now if you look at it, जो मैंने बनाया particular case, उसमें it appears कि it will escape to infinity, it won't collide, right, because there is a component joining the line along the line joining 2 to 1, but then 2 is constantly escaping away from it. Matlab, it is not coming towards it. Intuitively also it makes sense, right? So if you want the two particles to collide, what you would want is the entire velocity of 2 to be directed towards 1 as seen from 1, because agar 1 ke frame mein it's something like this, then again it won't collide with 1 because this is the in this direction particle 2 should have come, right? So what that means is velocity of 2 with respect to 1 has to be along the line joining them to satisfy the condition given in the question. So we can make use of vectors over here, v2 vector minus v1 vector by mod of v2 minus v1 mod. This basically gives you the unit vector, right? Unit vector of relative velocity is equal to minus of position of second vector with respect to first vector divided by r2 minus r1 का mod, because this is a unit position vector, so this will be the unit position vector of particle 2 with respect to 1, and this will be the unit velocity vector of particle 2 with respect to 1. So as you can see, these are clearly anti-parallel. So when you simplify this, the final relation that you would get is v2 minus v1 vector by v2 minus v1 vector का mod plus r2 vector minus r1 vector by r2 minus r1 vector का mod is equal to 0. So this should be the relation. So this is your answer. Hope it makes sense.